Now we're going to go backwards. We're going to find the equation. Let's see what they give us. We have foci of 2, 1, 4, 1, and 1 vertex. Well, I'm a visual learner, so I like to just kind of sketch that graph. All right, so 2, 1, 4, 1, those are my two foci, and I have one vertex at 0, 1. What does that tell me? Well, it tells me that I have a horizontal major axis. I also know the center is right between the two foci, and in this case I can just look at that. If that's if that's positive 2 and that's 4, then I know that the center is at 3, 1. That's good. That's H and K. So I can go ahead, I'm just going to fill that out. So H, K. Now I've just got to figure out A squared and B squared. Let's go back to those definitions, the distances. The distance from the center to each focus, that's the letter C. So in this case, C is 1. And the distance from the center to the end point of the major axis, which would be the vertex, let's see, that's 1, 2, 3. What letter is that? That's A. So if A is 3, then A squared is 9. Well, where does A go? Underneath X, or does it go underneath Y? Look at your picture, side to side. It's got to go there. So the only thing I need to know is what is B squared. Well, let's go back to here. Do I have all of those values except for B squared? I think so. C squared is 1, A squared is 9. Let's see, divide by -1. And I don't even need to know the square root of 8. I just need to know that B squared goes here. That's positive 8. That is a very typical type test problem. So look at the information you have, put it on a graph if that helps, and go back to that, what is ABC? Let's look at this one. This time they give us the center of H and K, and we give us one focus and one vertex. So we have a center at -3, positive 1. So I'm going to go ahead and start writing my equation. H is -3, so I want +3 here. K is 1, so I want -1 there. So I need A, B, and C. Well, A and B. Let's see, a focus is at -3, 0. And a vertex is at -3, 3. Well, the distance from the center to the focus, that's the letter C. And look at there, it's 1 again. Just coincidental, it's 1. The distance between the center and the endpoints of the major axis is A. So what's that distance? 2. And where does A go? Does it go underneath X or does it go underneath Y? Well, you might say it's not just A, it's A squared, and A squared is going to go underneath Y because it's a vertical axis, a vertical major axis. So I just need to know C squared. So that's 1, that's 4, and I think I said C, I meant B. Divide by -1, and so B squared is 3, and that's the equation of that ellipse. Another example, they give us the center, so that's H and K. They give us a focus, but this time it passes through just a point. So I have a center of 1, 2, have a focus of 1, 4, and it passes through the point 2, 2. Again, let's write down what we have. I need H and K, so that's H. I need K. Let's go through that again. So the distance from the center to the focus, that's the letter C. That's 2 units. So C squared is 4. That doesn't go there or there. what about here? Well, that's my center, and it goes to the point 2, 2. Wouldn't you agree, since it's perpendicular, it's straight over, they both have a y-coordinate of 2, that that has to be the tip of the minor axis. That would be a distance of b. And how far over is that? 1. So b squared is 1. And in what direction was that? Left or right or up and down? Left and right. So that goes underneath x. So I just need to know what a squared is. Going back here, so let's see, c squared is 4. I don't know a squared, and b squared is 1. So now I know that a squared is 3. It's kind of like putting together a puzzle. Fill in what you have, kind of figure out how to make the other pieces fit. Now we're going to talk about a whispering gallery. I really would like for you to Google a whispering gallery and see if you can come up with some real-life examples. There are. I've been in one. Okay, so what a whispering gallery is, it's a room in the cross section is half of an ellipse. So if you were looking straight onto the room, something like that. In this particular room, it's 40 feet high at its center and 100 feet wide at the floor. How far from the outer wall should Jamie and Jason stand so that they will be positioned at the foci of the ellipse? Right, so we want a person here and here, and they're asking how far from the outside of the wall. How am I going to get that? Put the information on a coordinate system. And pick your center probably to be the easiest place, so I'm going to pick my center to be 0, 0. This distance out here is 50 feet, and this is 40. Let's see what we have. So if I go and put 0 here and 0 here, well, I believe 50 is bigger than 40, so that's going to be A. That's going to be B. So A squared is 2500. B squared is 1600. What do I really need to know? Well, the distance from the outer wall to the focus, that's not anything. But the distance between here and here, that is little c, that's the distance between the center to each focus. So maybe I didn't even need that equation. So I know a squared is 2500, b squared is 1600. So c is plus or minus 30. Okay, so let me blow that up. So from here is 0 and out to here is 50. Here's 30 feet. What are they asking me for? How far from the outer wall? How far from the outer wall should they stand to be located at the focus? So this is the outer wall. How far inward? I need to stand 20 feet from the outer wall to be positioned at the foci of the ellipse. Our last example talks about an elliptical arch. Again, Google that. You're going to see some pictures of different things in real life that's made out of an elliptical arch. It's constructed where it's 6 feet wide at the base and 9 feet tall in the middle. Find the height of the arch exactly 1 foot in from the base of the arch. That means I'm going to go in 1 foot, and I want to know how tall that is. Well, that's not A, B, or C. I need to find a position on the graph, an XY coordinate. So that means, what is the Y coordinate? How far is that? Coordinate, where does that come from? You've got to create that XY coordinate system, just like we did before. So let's do it. Okay, so if this is total of 6 feet wide, this is going to be at 3, 0. This is at negative 3, 0. Up here, that's 0, 9. I'm going to make my center to be 0, 0. So I'm going to get an equation so I can find a particular x and y coordinate, because that's really what they're asking for. Well, the distance between here and here is 3, and that's in the x direction from the center, so that's going to be 9. 3 squared is 9. Here to here is 9. That's in the y direction, so that's 81. And you're saying, well, how's that going to help me find the height of the arch? Well, 1 foot in from the base. So here's the center, 1 foot in. So if this was at 3, 0, that means, so when x is 2, what is y? When x is 2, what is y? If I go out here 2, come up, how far? How can I solve? Using that equation. We're going to fill in 2 for x, leave y as y because that's what I want to solve for. So I'm going to subtract 4/9 from both sides. That's going to leave me 5/9. I'm going to cross multiply just to get rid of those fractions. And then I'm going to divide by 9. And yes, you can punch this into the calculator. I just don't happen to have one handy right now. So 9 goes into 81 9 times. So y squared is 45. So y is going to be the square root. And I'm not going to worry about plus or minus because I'm going up, so I know it's positive. 3 square root of 5. So how far do I need to go up? 3 square root of 5. You can punch that in and give me a decimal approximation. That's fine. But this would be the exact value. So the height of the arch, exactly 1 foot in, would be this far. I could now ask you, well, how tall is it 1 foot from the center? You could solve all of those.